In this video, I'll talk about IPv6. IPv6 is Internet Protocol version 6. It's not as widely used currently as IPv4, which is ubiquitous everywhere on the Internet. However, it was designed with security in mind, in the form of IPsec. It was also designed with media streaming or quality of service in mind for applications that might deal with audio, video streaming, or voice over IP transmissions over a packet-switched network. In IPv6, interestingly, there is no such thing as software broadcasting as there is often in IPv4. IPv4 dealt with subnet broadcasts, all-network broadcasts, ARP broadcasts, DHCP discovery broadcasts, and so on. That doesn't exist with IPv6. What does exist is unicast from one to one, which is also possible with IPv4, as are multicasts. A multicast transmission goes from one device to a group of registered listening devices on that multicast address. In IPv6, that's used for neighbor solicitation messages to discover other IPv6 devices on the network. IPv6 has something that IPv4 doesn't in the form of anycast transmissions. Now, an anycast transmission is similar to a multicast, but the distinction is that it seeks out the nearest member of a multicast group. IPv6 addresses are 128 bits long, and they're expressed in hexadecimal. Now, hexadecimal means that we've got letters A through to F, where A is used for number 10 and F is used for number 15. Of course, we have our standard 0 through to 9 for our regular digits. Now, with IPv6 addresses, each 16 bits, we'll call that a hextet, is separated not by a period, but rather by a full colon. Seen in our example, you can use a double colon once within an IPv6 address to represent a series of zeros, which is really the absence of a value. With IPv6, the subnet prefix length determines which portion of the IP identifies the network versus host. So it's kind of like the subnet mask in IPv4. And it can be expressed in CIDR form, which it normally is, such as /64. It means there are 64 bits in the subnet prefix. There are special IPv6 addresses such as ::1, which means local loopback. This is used when troubleshooting our local IP stack. Addresses beginning with FE80 are self-assigned link local addresses in IPv6, and this will always exist on an IPv6 host. It allows LAN communication only, but it lets it discover nodes on that network. Here in a Windows command prompt, if I were to type ipconfig, and I'm running Windows 10 on this station, I would see that I've got IPv6 addresses available. For example, for my Wi-Fi adapter, I don't have any IPv6 because it's disabled for that adapter. But if I take a look up at my connection Ethernet 3 here, I see that I've got both a link local IPv6 address, so it begins with FE80, and that never goes away. Well, the only way it goes away, of course, is if you turn off IPv6 entirely on your network interface. I've also got another IPv6 address that was manually assigned to this interface in the form of 1:2:3:4::, which means a series of zeros, 1. IPv6 addresses starting with FF00 are multicast packets. If the prefix is 2000, then it's called a global unicast packet transmission, which is essentially a public IPv6 address. Other settings for IPv6 are very similar to additional settings for IPv4, such as the default gateway, the IP address of a router on your network, allows communication outside of the LAN, and of course there could be multiple default gateways. You're not limited to having only one. DNS servers play the same role in IPv6 as they do with IPv4. They are lookup servers that do not have to be on your network, and they allow connection to services by name, which are, the name is easier to remember than the IP addresses, especially with IPv6. So the interesting thing about this, of course, is that when we build a host record in a zone in DNS. So that would be a lookup record that has a name that maps to an IP address. In IPv4, that's called an A record. In IPv6, it's called a quad A record, or AAAA. In this video, we discussed IPv6.